El agua es un recurso preciado que debe gestionarse de manera sostenible. Debemos cuidar nuestro patrimonio hídrico y anticiparnos a los nuevos escenarios climáticos que advierten de que cada vez habrá menos agua disponible. Los planes hidrológicos de tercer ciclo 2022-2027 conforman una herramienta clave para reorientar la gestión del agua, alineándola con la Directiva Marco del Agua y el Pacto Verde Europeo. La nueva planificación hidrológica nos prepara ante los efectos adversos provocados por el cambio del clima, invirtiendo la tendencia en el uso del agua y adecuando las asignaciones del recurso a la nueva realidad a la que nos enfrentamos. Las infraestructuras que se proyectan responden a criterios de necesidad y oportunidad y prestan atención a su mantenimiento y seguridad. Debemos recuperar nuestros ríos y acuíferos, impulsando la Estrategia Nacional de Restauración de Ríos y desarrollando el Plan de Acción de Aguas Subterráneas. Todo ello permitirá recuperar la salud ambiental de nuestras aguas y sus ecosistemas. Renaturalizar nuestros ríos nos protegerá frente a inundaciones, especies exóticas invasoras y nos ayudará en la adaptación al cambio climático. Para garantizar su función ambiental, los planes avanzan en la implementación de un adecuado régimen de caudales ecológicos para devolver a nuestros ríos sus funciones originales. La nueva planificación hidrológica impulsa la depuración y la reutilización a partir de la innovación tecnológica y las medidas desarrolladas en el Plan Nacional de Depuración, Saneamiento, Eficiencia, Ahorro y Reutilización. Un factor clave para mejorar la calidad del agua, al tiempo que se reduce el impacto en el medio ambiente. El alto contenido de nitratos en ríos y acuíferos es uno de los principales problemas para nuestros recursos hídricos. Los nuevos planes hidrológicos afrontan el problema y establecen medidas concretas para reducir la concentración de nitratos en las masas de agua afectadas. Uno de nuestros objetivos prioritarios es la protección de hábitats y especies, impulsando la figura de las reservas hidrológicas y prestando una especial atención a espacios emblemáticos relacionados con el agua, como el Delta del Ebro, el Mar Menor, Doñana, el Alto Guadiana o la Albufera. Debemos trabajar entre todos para conseguir el buen estado de nuestras masas de agua. Solo así podremos garantizar la seguridad hídrica, la protección de la biodiversidad y reducir nuestra vulnerabilidad frente al cambio climático.
Bonjour à tous, merci d'être encore une fois présents aujourd'hui, fidèles à nos rendez-vous de l'Institut Méditerranéen de l'eau. Chers amis de l'eau, je tiens avant toute chose à adresser tous mes voeux de bien-être et de réussite à tous nos membres musulmans à l'occasion de l'Aïd. Et je tiens également à leur présenter toutes nos excuses pour avoir programmé notre conférence en cette période. Mais c'était difficile de faire autrement. Et merci à nos intervenants jordaniens pour avoir accepté cela. Comme vous le savez, nos conférences sont toutes enregistrées et ensuite publiées sur notre chaîne YouTube la semaine suivante, en français comme en anglais, pour ceux qui n'ont pas pu se libérer aujourd'hui. Nous sommes aujourd'hui encore plus de 160 inscrits et représentant plus de 20 pays, et je vous remercie de cette fidélité. Cela nous encourage à poursuivre notre action. Cette série de conférences sur la planification de la gestion des ressources en eau en Méditerranée se poursuit après la France et la Tunisie, Malte et le Maroc. C'est aujourd'hui le tour de l'Espagne et de la Jordanie. Merci à François Gerber pour le travail de préparation et l'animation, aux intervenants et aux équipes de l'IME pour leur professionnalisme. Je tiens à vous rappeler que ces conférences organisées par notre comité scientifique et technique ont pour but d'enrichir les 6 thématiques de notre prochain forum méditerranéen de l'eau Tunis 2024, à savoir, premièrement, l'Alliance eau, énergie, alimentation et environnement, pilotée par Juan Reda de TIPSA, la nouvelle vision de l'offre à travers le mix hydrique et de la demande à l'horizon 2050, pilotée par Ramiro Martinez du REMOC, la prévention, et le management des sécheresses et inondations piloté par Alix Romagnac de la société Predict, la régulation, le droit à l'eau et les droits d'eau, conflits, prévention, résolution, piloté par notre président du CST Mokhtar Bzioui, que je salue, assisté de Fadi Komer de l'Institut de Chypre, expert en hydrodiplomatie. Cinquièmement, les cinquièmes sessions, les nouveaux partenaires de la finance de l'eau et le monitoring de la performance piloté par votre serviteur. Et enfin, la digitalisation et les nouvelles solutions dédiées à un usage rationnel de l'eau, piloté par Nicolas Roche de Aix-Marseille Université, membre de l'IME. En introduction, je souhaite vous parler de deux sujets d'actualité, à savoir la réalisation du premier atelier d'échange international sur le thème de la création d'un observatoire des ressources en eau non conventionnelles et des énergies renouvelables associées qui s'est tenu à Rabat la semaine dernière, co-organisé par l'Office national de l'électricité et de l'eau et l'IME, et également, deuxièmement, les 21e rencontres du HELP, High Level Expert and Leader Panel on Water and Disasters, qui s'est tenu à Madrid en début de cette semaine et au cours duquel j'ai eu l'honneur de représenter le président du Conseil mondial de l'eau, Loïc Fauchon, en ma qualité de gouverneur du Conseil. L'objectif de l'atelier de Rabat était de présenter les expériences réussies du Maroc, ONIE, Office national d'électricité et de l'eau, l'OCP, l'Office chérifien des phosphates, et Mazen, la société spécialisée dans la réalisation et l'exploitation des systèmes énergie renouvelables. Et d'autres pays méditerranéens, l'Espagne avec Aguas de Barcelone, TIPSA et la région de Murcie, et la Tunisie avec la SONED, sa société d'eau potable nationale, et l'ONAS, l'Office national d'assainissement. Ceci dans le domaine du dessalement de l'eau de mer et de la réutilisation des eaux usées et des énergies renouvelables associées. Un rapport est en cours d'élaboration avec la participation de l'ensemble des participants, que je remercie également, et sera prochainement mis à votre disposition. Je profite de cette occasion pour remercier à nouveau les autorités marocaines et notamment le directeur général de l'ONE, M. El Afidi, ainsi que sa directrice de la coopération internationale, Asma El Kasmi, et ses équipes pour avoir permis la réalisation de ce premier atelier sur cette thématique chère à l'Institut méditerranéen de l'eau et au Conseil mondial de l'eau. Celui-ci sera suivi de deux autres ateliers, dont le prochain se déroulera à Valence, Espagne, suite au kick-off du 5e Forum méditerranéen de l'eau de Tunis 2024, kick-off qui doit avoir lieu le 18 octobre. Donc, le 19 octobre, nous vous proposerons prochainement d'organiser un deuxième atelier pour mieux définir le contenu de cet observatoire ainsi que son fonctionnement et inviter également d'autres pays à présenter leurs expériences et leurs success stories. Nous vous confirmons cela dans les tout prochains jours. Sur le même sujet, je vous informe que le Conseil mondial de l'eau a désigné l'Institut méditerranéen de l'eau pour piloter la task force correspondante, ainsi que le fait que nous avons fait acte de candidature à la co-organisation du sujet économie circulaire et ressources en eau non conventionnelles de la sous-thématique 1 du prochain Forum mondial de l'eau, Water Security and Prosperity. Notre participation, deuxièmement, aux 21e rencontres de HELP, nous a permis de souligner les points suivants. La thématique eau et désastres naturels a toujours été présente dans nos travaux, que ce soit en termes d'inondation comme de sécheresse. Avec l'impact des changements climatiques, son importance s'est amplifiée et a atteint les pays de l'hémisphère nord, jusque-là épargnés. Depuis la sécheresse de 2022, cela a généré un nouveau risque pour les activités économiques et les entreprises, aussi bien que pour les particuliers, ce qu'on appelle aujourd'hui le water risk. Si l'on considère que les phénomènes de crues rapides et sécheresses persistantes vont s'établir durablement, comme le prévoit le dernier rapport du GIEC 2023, personne n'est épargné, les pays pauvres comme les pays riches, et leur économie avec. Les agences de notation et les fonds souverains intègrent aujourd'hui le water risk dans leur évaluation. Ceci constitue un nouveau départ à travers la prise de conscience et l'implication directe du secteur privé marchand qui a largement contribué à la croissance de ces 50 dernières années en ignorant l'eau. Le président du Conseil mondial de l'eau le rappelait lors de la conférence des Nations Unies sur l'eau qui s'est tenue à New York en mars dernier. Arrêtons d'ignorer l'eau. Et je rajouterai, respectons-la, c'est notre meilleur ami. Un certain nombre de grands groupes, dans des secteurs aussi variés que l'industrie minière, comme l'Office chérifien des phosphates au Maroc, qui sera prochainement en 2025 autonome en eau, ou l'agro-industrie, avec un groupe comme Danone, qui anticipe la sécurisation de ses entrants, qui pour 80% viennent de l'agriculture locale, ou le monde des assurances avec le groupe AXA qui a créé AXA Climat pour assister le mieux possible ses clients industriels, agricoles ou services, non seulement ont compris les enjeux du water risk, mais l'ont intégré comme contrainte de leur stratégie de développement, pour ne pas dire de survie à moyen et long terme. D'autres suivent déjà. Je vous remercie pour votre attention de cette introduction et je vous souhaite une excellente conférence. François, encore merci pour ton implication et l'organisation de cette conférence. La parole est à toi.
Bon, merci Alain donc, pour cette introduction. Ça va me permettre d'être très court puisque tu as déjà bien vanté les mérites de notre série de webinaires et surtout leur objectif qui est de contribuer par des expériences très concrètes et des expériences réussies de tous les pays à contribuer donc au Forum méditerranéen de l'eau de Tunis en janvier prochain, qui lui-même sera un moyen de contribuer au Forum mondial de Bali au printemps suivant. Donc, sans attendre plus longtemps, je crois que les exposés, justement, vont nous donner des exemples précis, que ce soit sur les économies d'eau, la prospective sur la baisse des ressources, les ressources en eau non conventionnelles telles que le dessalement ou la réutilisation qu'il faut mobiliser, peut-être les finances aussi. Tout ça va venir de ces exposés. Donc, nous commençons aujourd'hui par présenter le cas de l'Espagne et ensuite le cas de la Jordanie. Donc, je remercie bien entendu nos intervenants qui ont travaillé pour vous présenter des diaporamas très intéressants. Nous leur laissons donc juste 15 minutes à chacun pour présenter l'essentiel, de manière à avoir à la fin de la réunion des questions. Donc pour ça, vous pouvez utiliser les questions, le chat, pour poser vos questions par écrit. Les participants n'ont pas la possibilité de les poser eux-mêmes, mais moi-même, je sélectionnerai les plus intéressantes pour redonner la parole en fin de séance aux intervenants. Voilà, donc pour commencer, donc je vais passer la parole à Monsieur Javier Poza Rodriguez, qui est chef de service gestion et coopération à la planification hydrologique de la Direction générale de l'eau au ministère espagnol qui s'appelle, c'est pas que le ministère de l'eau, c'est la transition écologique et le défi démographique. Voilà, merci Javier, et à vous la présentation.
Javier, your microphone is off.
Okay, bonsoir, good afternoon. First of all, I would like to thank the Institute for inviting me to this webinar. And let's see if I can share my presentation. You're seeing it now. So I'm going to speak about water planning in Spain, starting with some facts and figures about Spain. Everybody knows that Spain is located in the western part of the Mediterranean region. And we have an area of 500,000 square kilometers, a population of 47 million inhabitants, a density of population of 94 inhabitants per square kilometer, and a gross domestic product of 1,350 millions of euros, which situates us in the 14th position of the ranking in the world. And we have a GDP of 28,000 euros per capita. Speaking about the rain in Spain, the average precipitation is 640 millimeters of rain, but it ranges from 200 in the southeast to 2,000 in the northwest. The total runoff is 111,000 millions of cubic meters a year, of which 81,000 millions are surface water, and 29 millions correspond to groundwater. Let's see. In Spain, we use a total of 31,000 millions of cubic meters a year, distributed in such a way that 81% of our use is dedicated to agriculture, mainly irrigation, and 16% of the use is dedicated to urban supply, and only 3%, is dedicated to industrial use. If we look at it from the point of view of the origin of the water we use, we see that 75% corresponds to surface water, while only 25% corresponds to groundwater. If we see this in a map and taking into account the climatic circumstances of Spain, in which rainfall in the northwest part is much more abundant than in the southeast part, and that most of Spain has a Mediterranean climate where we have high temperatures in the summer and low precipitation in that summer, which is the least rainfall season in the year, which is the moment that can be seen here in all the climate diagrams that I present here in the figure, which is that the traditional Mediterranean climate, which you can see here in this area of the map. Due to this, our traditional water planning in Spain, the one that we've been implementing since the beginning of the 20th century, starting with the general plan for irrigation channels and swamps of the year 1902, or the hydraulic works plan of the 1933, and the subsequent actualizations of those were based on the idea of an uneven distribution of rainfall, both geographically and seasonally, which had to be corrected. In this sense, in the past, we have put all the efforts in adapting to this seasonal uneven distribution of rainfall, in which the months with more precipitation, late autumn, are not the months of greater water use or water demand. This leads to a situation in which, in the natural regime, most of the runoff cannot be used without regulation. That's why during the last century, mainly since the 50s, a large part of the investment effort has been put on the service of the construction of dams. This has led Spain to be the leader in this sector, with more than 1,800 reservoirs built, and with a capacity of regulation rising up to 55,000, well, I say here cubic hectometers. I'm sorry, because in some countries this is probably not well understood, millions of cubic meters. If you remember from the first slide, this represents approximately half of the runoff in Spain. In the same sense, in order to solve the idea, or that ancient idea, of an uneven geographical distribution of water resources A large part of the efforts of traditional hydraulic planning policy have been aimed at rebalancing water availability between regions. For this, numerous water transfers have been built. The most important water transfer is the one named Tajo Segura water transfer, which was devised in year 1922. And it was first included in a plan in 1933, but it was not until 1979 that it became operational. As you can see, this type of solutions take a very considerable period of time to be completed. These water transfers brings water from the center of the peninsula to the southeast. And as an average in the past, it has transferred a volume of 315 hectometers per year, mainly for irrigation, but also for urban supply and a small proportion also for environmental purposes. But the transfer has not been done with some controversy, mainly from the environmental NGOs, but also from the regions, the seeding regions and the seeding river basins. And this is a solution that was thought in the past and that needs to be maintained in the present, but clearly must be adapted in the future. In Spain, we have other water transfers. 10 of them are important water transfers with an annual volume greater than 5 cubic hectometers per year. And within those 10, 6 of them are greater than 50 cubic hectometers. If you go to the side of the modern water planning, we see that we have different types of objectives, not just the satisfaction of water demands, but we have to comply with environmental objectives mainly established by the Water Framework Directive. Probably in the next presentation, Nieves is going to give you an overview of our actual or current river basin management plans. But just to say that those objectives are for surface waters, the good ecological status, the good chemical status, for groundwater, the good quantitative status and good chemical status, and then for protected areas, the objectives for which they were identified, like drinking water, bathing, or selfish production. Our plans also include some measures to manage extreme weather events like droughts and floods. And also there's the tradition to include some other measures to satisfy other uses, including public use. And of course, there are governance and knowledge measures in our plans. The key principles of water management and water planning in Spain are those that are shown in this slide. So the first one is the management unit, the comprehensive treatment, water economy, the concentration, decentralization, coordination, effectiveness, and in the past, user participation. Nowadays, we are changing a little bit between this user participation to a more wider participation, saying public participation, which includes all the citizens and not just the users. One of the main principles is the respect of the water seed management principle, the non-division of the hydraulic systems and the hydrological cycle. The compatibility of public water management with land use planning, environmental and conservation and protection and restoration of nature. And also there was a change in the late 90s for the joint use of surface and groundwater with the whole water cycle. The river basin is the unit of planning. This is quite clear in Europe today, but Spain in the past was the pioneer country in river basin management because we have river basin organizations in place since 1926 with the creation of the first river basin district in Spain, Confederación del Ebro. Those are the 25 river basins that we have nowadays in Spain, and we have one river basin management plan for each one of them. I've been asked to talk mainly about water demands. And for these water demands, we have a complex system of water allocations and also a permitting system in which we store all the information related to these water rights. And we use a modeling methodology to do this. We have the water rights from the different sectors, urban, agricultural, industrial, and for the production of electricity. So it's thermal, nuclear, or hydropower, other industrials. We group them in what we call units of demand. And then those units of demand, we group them in exploitation systems. And with this, we calculate or we introduce in the modeling tools that we have. Some of them we have developed specifically for this with the collaboration of the University of Valencia. We have the current water demands. And then on the other side, we have the natural water resources. We have extensive monitoring network of precipitation, temperature, and so on, which we differentiate surface water, which we can take directly from the river or whatever, or through regulation, as we mentioned before, groundwater, through abstractions. But we also use other water resources like water transfers and water reuse and desalination, what we call non-conventional water resources. With this, we include in our model the restrictions due to ecological flows and ecosystem needs, and this gives us the available water resource offer. With this offer, and using some criteria, which I'm going to explain a little bit afterwards, we carry out a balance, but not a balance just in the current situation, but we produce also trend scenarios with the foreseen changes in the drivers in agriculture, urban, and we produce different scenarios, 6 years, 2027, 2033, and for the sake of climate change, 2039. And then we also produce climate test scenarios for the available resources, including both climate change and also the measures that we put in place to increase the availability of water resource. And we produce also balances here. With this, we decide on the measures. Traditional measures go on the side of the increasing the offer of water. But nowadays, we are more in the sake of reducing water demands. Both things are with the same importance. But in the current river basin management plans, only 28 new dams have been included. And if you remember from the first slides, we have 1,800 reservoirs. So the possibility to build new dams is quite limited. And there's an investment of more than 300 million euros. If we speak about water transfers, there's only one new transfer in project. So you see that from the side of increasing the water offer, probably we will not have very much success. So we are now looking at those non-conventional water resources and the reduction of water demands. What are the kind of criteria that we use to calculate these balances? Well, the first thing is the concept of water demand. So it's the volume of water in quantity and quality that the user is willing to acquire at a specific price and specific circumstances. And the criteria for urban demand is that the deficit in a month does not exceed 10% of the corresponding monthly demand, and in 10 consecutive years, the sum of deficit does not exceed 8% of the sum of annual demand. And also for planning purposes, the deficit in agricultural demand of 1 year should not exceed 50% of the corresponding demand, but in 2 consecutive years, the sum of deficit should not exceed 75% of the annual demand. And in 10 consecutive years, the sum should not exceed 100% of the annual demand. This can be adaptive if there's livestock is important in the basin or in the unit. And also we should take into account this forecast of changes in climate change. There's a study from 2007 from the Center of Hydrographic Studies, which you can see here in the left side, and using the most common scenarios. And producing three types of estimates, the one more optimistic to the more pessimistic. The reduction in precipitation and runoff is probably something quite clear in all the different scenarios. So we have to be prepared to adapt to these possible changes. If we speak of those non-conventional resources, which is something that is probably the future, water reuse, there's a lot of experience in Spain. This has been regulated since 2007. Recently, we have adjusted the water law to adapt it to the European regulation on the use of their use of water for agricultural purposes. Water use in Spain in 2001 amounts for 400 cubic hectometers a year, which is approximately 1.3% of water use in Spain. In our new river basin management plans, we have 123 new measures of water use with an investment of nearly 600 million euros. In the past, we were speaking about the analytical control in this royal decree, which has been repealed just, 3 days ago. So it's quite recent. This has been repealed, not totally. So some of these values that you see in this table, which are values for an analytical control, are still in force, not those for agricultural. The new system is based on a risk analysis, and it's in force since just this week. And it also includes the promotion of water reuse with the possibility of public funding if it's necessary to comply with river basin management plan. And mainly in discharges to the sea, where we get a net increase in water resources in the basin. With water desalination, it's quite the same. You see in the left side the location of 55 major desalination plants in Spain. Spain is the third country in the world by capacity of desalination. We have more than 900 desalination plants with a production of 1,404,000 cubic meters a day. This accounts like 5,500 cubic hectometers a year, which represents 1.6 of water use in Spain. And in our new plans, we have 79 desalination measures, 8 of them of brackish water with an investment of nearly 1,000 million euros. So nowadays, non-conventional water resources represent approximately 2% of the total water use in Spain. And this is probably one of the challenges that we have nowadays. The other one is the implementation of those ecological flows, which is one of the issues of greatest concern for the hydroelectric sector. In the third cycle plans, ecological flows have been established for all water bodies. And compliance with these flows in some cases is associated with the need to adapt the drainage organs or the outfalls of the dams. And this is a challenge for the sector. And on the other hand, the issue of rates of change, so the speed of change of the flows released, and the possible conflict with the needs to collect electricity demand peaks is another one of our challenges. And with this, I would like to end my presentation. Thanks for your attention. And I will leave the floor to Nieves, who will probably give you more details on how our river basin management plans are, what is the process and what they include. But if you want to find more information, I leave you here the link to the IT tool that we have to see all the information on our river basin management plans, and also the link to the website page of the ministry where you can find the text of all the river basin management plans in Spain. Thank you very much.
Merci beaucoup. Thank you very much, Javier. So Nieves will show a presentation now. Nous allons passer donc de la vision nationale à une vision plus détaillée sur un bassin versant et donc l'unité de planification. Nieves, the floor is yours.
Okay, good afternoon. It's a pleasure to be here in this webinar. thank you to the institution and to the audience. And continuing with this Spanish case, I will share my screen and yes, can you see the presentation? So I will present you the water planning of one of these Spanish districts, the Júcar River Basin. And I have structured my presentation in 3 parts: the water planning in Spain, the main figures of the Júcar River Basin, and the challenges and solutions in relation to agriculture and hydroelectric energy, which were the main themes of this seminar. And beginning with water planning, we have to keep in mind these general objectives that were told already by my colleague. We have to achieve the good status of water bodies. This was incorporated in the year 2000 by the European Water Framework Directive, but we also have to meet water demands. And in addition, we have to mitigate the impacts of floods and droughts. This we make in a cyclic process every 6 years. We make new river basin management plans and also the flood risk management plans. This is a process in which public participation is present from the very beginning. And at the end, we come to have this river basin management plan, the flood risk management plan, which are a great amount of documents, descriptive documents, their annexes with all the descriptions and details. There is a normative document. We also prepare an informative document, and the same with the flood risk management plan with a descriptive document and the annexes. And we also prepared the strategic environmental assessment. All of these documents are available at the web page of the Júcar River Basin. With a 2-year delay, we also make the drought management plan, which consists also of one descriptive document and its annex. And we prepare also a strategic environmental assessment. And moving just now to the Júcar River Basin and to the characterization of this district, we are located in the east part of Spain, in the Mediterranean Sea. And the main figures are here. It is a territory of over 40,000 square kilometers, almost 5.5 million people live here. And in this geographic area, we have 5 regional governments and also around 800 municipalities. The irrigated surface is 375,000 hectares. We have 51 hydroelectric demand units, and the water demand of all the river basin calculated for 2018, which was the reference year for the last water management plan, is slightly over 3,000 cubic hectometer. The share of the different uses can you see in this chart. The same, mostly the same of the national shares, 80% agriculture, irrigation, and 16% urban supply and 4% industry. Here you can see in these maps the location of the agriculture, mainly in the flat land in the coast and also in the flat land in the inland. And on the right part, you can see the hydroelectric demand units located in the 3 main rivers of the river basin. The crops that we have are very varied. You see here a sample of them. And of course, we also have tourism and a lot of population. Almost 8% of the population living in this territory are not permanent ones because of the tourism, which is the most important economic activity in the territory. So, and which resources do we have to supply these water demands? We have natural resources. We have a total inflow of slightly over 3,000 cubic hectometer per year. But the distribution again is the same like the national overview that told Javier, my colleague. We have an uneven distribution in the territory, and also in the years, along the years, we have wet years with 700-800 millimeters and dry years with more or less 300 millimeters precipitation. And we have an average of 500 millimeters. So, and what else can we do we have? We have other resources. We have seawater, so we have a potential seawater desalination of 65 cubic hectometer per year. It's an important one. We have also water reuse, and potentially we could have 300 cubic hectometer. And we also have a bit volume of transfer in the south part. And it is important to highlight the importance of groundwater in this basin, because 50% of the water demands are satisfied by groundwater. And we also have the flow of the rivers are proceed from groundwater in a 75%. So if you remember what the national overview was, the water demands were only supplied in a share of 25% with groundwater. So in our river basin, groundwater is really important. Then we can see in this chart the shares of the different origins of water and potential origins. It's not mean that we have really 8% of water use or 2% of desalination. So it is the potential resources. So with this context and this overview of the river basin, we can imagine that the challenges, the main challenge of this territory is to have a balance and to make compatible the environmental objectives and the water demand satisfaction. And water demand cause really some important problems, and I want to highlight 3 of them. The first one, the hydrologic and morphologic alterations. Here you can see the inflow of one reservoir and how the regime is total embedded when we look at the outflow. We have also derived caused by agriculture. We have diffuse pollution. It's very important in the groundwater, but also is present in surface water. The nitrates surplus comes into the water and pollutes it. And the last one is the piezometric level decrease, which is very intense in some parts of the river basin. So, and how can we approach the solution of this, of making compatible these 2 main goals of the water planning? With a planned, integrated and sustainable management of all resources, including conventional and non-conventional. And I want to highlight 3 aspects, which are the water allocation process, which was also said by Javier, the program of measures, which is included in the water river management plans, and the process of approval of the river basin management plans. And I mean that water allocation process, in this process, we consider ecological flows as a restriction. This is a warranty. And we make water allocation in line with water availability. The second aspect is the program of measures. We have a very collaborative definition of the program of measures. All the sectors and all the actors are present and propose the measures, which are included in the plan. And the last one, the process of approval. The Spanish water law requires that by the approval of the river basin management plans, there must be the conformity of the competent authorities committee. That means the authorities, the administrations that are responsible of the different sectors involved. And we have to have a report of the Water Basin Council and of the National Water Council, where there is represented not only the administrations, but also the users and other stakeholders. So, and which are the solutions that are included in the Juca River Basin Management Plans for tackling with these main 3 problems that I was telling before? One thing is ecological flows regime. We define a minimum, maximum flow change rate and a channel forming discharges in the plans. And this we make in a consultation process with the users, mainly the hydroelectrical sector, which are the most affected one. There you can see the evolution from the very first plan to the last one, and how we have improved in the definition of the different components. There is still work to do, but I think we can see a good progress. Another solution for pollution reduction and pumping savings are included in the plan. We have defined restrictions to fertilization practices and control measures, and there is a big group of projects of modernization of irrigation infrastructures, which are planned to be done in this 6-year where we have to implement the plan. We have projects in nearly 50 unit demands in an area of 42,000 hectares. The water savings that we estimate are from 2,500 to 3,000 cubic meter per hectare and year. That means a total volume in the Júcar River Basin of 130 cubic hectometer. And in these areas, irrigated area extension is not allowed. So, and here in this table, you can see the evolution of the reduction of the water demands. These are total water demand, but the main reductions come from this modernization of irrigation infrastructures. You can see from the second last plan to the scenario in the year 2018, we have a reduction. And then again, we estimate that we will have another reduction when we reach 2027. And with these modernization projects, we also have less pollution because of the use of less fertilizers and pesticides. And I want to present you an example of these projects. The most big one, it is the Royal Júcar Canal modernization. It began in the year 2005, and it is programmed to continue until 2027. We have 14,400 hectares, and the water savings in total in these different phases would be 45 cubic hectometer. On the map, you can see in different colors that there are different administrations participating in these projects. National by the ministry, but also public state companies, and also the regional government will make some of the modernization projects. And the efficiency here improves from 0.5 to 0.8. And it is estimated, it is estimated that fertilizers and pesticides reductions are present, and for the nitrogen, it would be 35 till 40% less with these projects. We have.
Yes, can you conclude, please?
Yes. Okay, I go faster. There is also pumping replacement, and we focus on desalination for urban use. We have an allocation of 60 cubic hectometer per year for urban supply, current and future, and this would improve the status of groundwater bodies, because if you see in the map, the desalination plants were built in the surroundings of groundwater bodies where the status was not good, so that we can replace pumping. And we have also water reuse. This meant for irrigation. We have also already an allocation of 271 cubic hectometer. In a more short term, we will use 134 cubic hectometer, and the others in the late phase. There is also one environmental restriction. It improves the groundwater, but also the surface water bodies, because we reduce the volume discharge in the environment, and this ensures also a higher guarantee for users. Finally, I would like to highlight the importance of the water use control. If we speak about quantity, we need monitoring and gauging methods, and remote sensing are the instruments. And to conclude, again, this slide where we have these three main ideas of water allocation in line with water availability, program of measures collaborative with other administrations and sectors, and the approval process with the involvement of all the stakeholders. And that's all. Thank you very much.
Okay, thank you very much, Nieves. Muchas gracias. Comme le temps nous est compté, ce que je vous propose, c'est de passer maintenant la parole pour présenter le cas jordanien de Jordanie avec deux exposés. Et j'ai déjà noté quelques questions que l'on essaiera de poser à la fin, si on peut déborder un peu sur le temps. So, Mr. Aldewari, the floor is yours. Ida will show the presentation.
Yes,
if you're ready to speak.
Yes, thank you, and thanks for the invitation, and thanks for the audience. Please, yes, I will try to make it quick and short and straightforward to the points. Please go to this next slide. I will focus at the beginning on some facts about the water sector in Jordan, as well as some challenges that we are facing. In general, Jordan is the second water poorest country in all over the universe. So you can see how the challenges that we are facing. We have around 100 meter cube of annual renewable water resources is available per person, which is it's far away from the absolute water scarcity line, which is agreed universally as 500 cubic meter. Jordan composed of 15 surface water basin, as well as 12 ground basins. One of the main challenge or the main issue that we are facing in the Jordan is the transboundary water. Around 40% of our water budget is shared water. We have three countries that we are sharing with them: Israel, Syria, and Saudi Arabia. We have many agreements that managing and coordinating the relationship with these countries, but this kind of management and relationship either goes ups and downs, so based on the political and many other factors. So this kind of shared water it's a fact, and as well as it's a challenge also. Our water budget in general, in principle, let's say it's around 1,000 million cubic meter. 28 to 30% is surface water, 15% around that number is treated wastewater, and 57 to 60% is groundwater. You can see that Jordan, we are putting a huge pressure behind the non-conventional water resources utilization, and we are good in the wastewater treatment as far as we are consuming most of our treated wastewater, mainly in the agriculture activities. And we are consider ourselves as one of the pioneer country in the region when it comes to the wastewater utilization. But that for sure are not coming with no challenges. We have a huge challenge behind how to manage the wastewater assets and how to make it more efficient and more effective and so on. The number of the wells in Jordan around 3,000 something. It's a fact that represent how many wells that we are digging in Jordan just to look for the groundwater and to enhance the abstraction. Given the fact that most of our groundwater basins, they are depleted because of the over abstraction, since we are facing a shortage in the water precipitation. Please slide in the next slide. Next slide, please. Yes. The groundwater in Jordan is dropped from on average 2 meters per year, or some ground aquifer they are between 5 to 20 meters. The drop of the water service in the groundwater. So you can see how the challenge that we are facing in Jordan when it comes to and that should be reflected on the cost of the O&M, because as far as you are pumping the water from very deep water and in your aquifer, it means that you are consuming more energy, and more energy, it means more money and so on. The safe field abstraction in Jordan is 275 MCM, million cubic meter, and the safe field abstraction of the non-renewable groundwater for the coming 50 years is around 143. The non-renewable groundwater is the southern part of Jordan, that the groundwater, the basin that we are shared with Saudi Arabia. We are utilize that groundwater right now through the DC project, we call it. We are pumping around 140 MCM per year. It's for drinking purposes, mainly for drinking purposes, and that water is coming from the south part of Jordan to the middle Amman. Then it will be distributed all over the country through many distribution or transformation pipelines, then through the distribution network. And I will come later about this project. One of the biggest consumer in Jordan of water is the agriculture sector. They are consuming around 50% of our water budget, and it's a huge challenge that how to manage the relationship with the agriculture sector. And based on that, we start to think in Jordan how to institutionalize the relationship with the agriculture sector as well as with the energy sector. Because the water sector is one of the biggest consumer of energy in Jordan, as well as the agriculture sector is it's our biggest consumer of water. So like we are consuming more energy, and they are a big consumer, which is the agriculture. So the relationship, it should be more in a systematic way rather than this kind of ad hoc relationship and the classical way of managing the relation between the ministries. We start to formulate some kind of what we call it nexus committee between the Ministry of Water and Irrigation, our ministry, as well as with the Ministry of Energy. And right now we are trying to expand the processes to include what we call it WIFI nexus, water, energy, food, and environment. We are still in the study of and to come with some conclusions. So based on that, I hope by the end of this year we will come up with a certain concrete setup that will manage the relationship with the 3-line ministers or 4-line ministers. As I mentioned, 50% of our water budget is consumed by the agriculture. Most of their almost half 50 of that 50% of that amount is coming from the groundwater. So also the groundwater is not only utilized for the drinking purposes, also it's for agriculture purposes. And here we are changing our policies and directions over the time by trying to substitute the utilization of drinking water, we call it, either it's from surface or groundwater in the agriculture sector, to be to replace by or to substitute it by treated wastewater, and that comes with a huge challenge, as I mentioned at the beginning. 94% of the water resources are described safely managed in Jordan. We are good in managing our water resources. 95.4% of population are connected to the water network pipes. Most of the population in Jordan, they are connected in the to the water services. But the modality or the mechanism how we are supplying the water in Jordan, it's I don't know if you heard about that. It's like intermittent kind of supply. We are not pumping the water continuously to the household. We are pumping the water, let's say once a week or every 2 weeks. And the people, they are receive the water, store it in their own tanks, and they utilize it for the coming either week or 10 days or 2 weeks. Then they will receive the water again, and so on. We call it intermittent. And this kind of supplying mechanism, it's affect our water network, and it's affect our the non-revenue water. We are facing one of the highest non-revenue water in, maybe in the region, and it's a big challenge to the water sector actually. As I mentioned, 50% of the Jordan population has 24 the water supply hour per week, or it's like a challenge or something like that. Please, next slide, please. Yes, thank you. We have many challenges in the water sector. Let's start with the fact that we are receiving many refugees and influxes from time to time. The last one was the Syrian refugees. We have around 1.4 Syrian who is living in Jordan. 50% of them, they are registered as refugees, and the other, they are just Syrian who came to the Jordan with their own passport. So, but in total, we have 1.4, something like that, or Syrian. So they are compared to the total number of population, which is around 11 million. So it's a big portion. Take into consideration, there are many other refugees, Iraqi and other nationalities. More than 90% of our rainfall evaporated. So we have on the long-term average of the water precipitation in Jordan, or the precipitation in the rain precipitation is 8,000 million cubic meter. 90% is evaporated. So we are not having that utilization of this amount of water in a proper way. The challenge, because our climate is a semi-arid climate, so the evaporation is high in our region. The groundwater is being used as twice a rate as which it can be recharged. As I mentioned, non-revenue water include both the administration and physical losses. On the average of non-revenue water is 50%. Just to clarify what non-revenue water means. Non-revenue water, it's the amount of the water that we are not accounted in our system, and when it comes to the billing mechanism. So we are pumping an X amount of water, and our the meters at the customer level or at the household level, they are measuring another amount of water. So the difference is the non-revenue water. Then NRW includes the physical losses, which is mean the leakage in the pipe, either because of the depreciation of the network, or because, as I mentioned, of the intermittent supply and many other challenges in the water network. And the administrative losses. The administrative losses includes the inaccuracy of the data. Inaccuracy of the data, or that mismanagement of the data, and sometimes illegal consumption. All these together, we call it administration losses. As I mentioned, the agricultural activities are consuming around 50% of the water budget in Jordan. And all the time we are mentioning that the agriculture sector or the agricultural activities, they are not supporting the GDP with a high rate. So still the contribution of the agriculture is very low when it comes to the GDP, even though they are consuming 50% of our water budget. So, I mean, they need to do some kind of reform maybe on their side, or to enhance their own mechanism. Jordan consumes more water than available of the renewable resources. It's because of the demographic change in Jordan, the increasing of population. We are expecting Jordan to be double over the coming 20 years, the population. So all these demographic change, the refugees influxes, the climate change, they affect the consumption of the water and put it at a high rate, so comparing to the available water. Limited financial resources. As you know, all kind of interventions, either directed to the water network improvement or water network rehabilitation, water facilities, wastewater, etc. We need to have finance, and our water sector is still subsidized by the government. The water tariff, it's not covering the whole cost that the government, that the ministry is paying for the water services. And when I mention the water services, it means the water and wastewater cost. So we still rely on the subsidies from the government and some other international agencies, either through grants from our different development agencies or through international loans. But sometimes these kind of loans, it's a challenge that to approach and to get them, even though they are available most of the time, the institutions. Dramatic increase in the operation and maintenance costs, especially for the electricity. Actually, in the water sector, as I mentioned, we are the biggest consumer when it comes to the energy, and any change on the energy tariff, it will affect us dramatically and sharply on the energy sector. On the water sector, I can just give you an example. In 2017-18, there was an increase on the energy tariff from the Ministry of Energy at that time. And this kind of increase affect us in a very bad situation, and it went us with our cost recovery ratio from almost 100% to the 57 or 60-70%, and that increase our financial burden and start to push us to think of developing, which is already has been developed the financial sustainability roadmap. I will come later about that financial sustainability. The huge distance between the water sources and the population. Most of our water sources or water resources, they are far away from our the center of people where are living. So this kind of far away distance, you can read that distance from another angle, which is the coast. So as far as you are away from your water resources, it means you need to pump the water for a very long distance. If you consume more energy, sometimes more losses, and so on. So this kind of also another challenge, as I mentioned, it will increase the energy cost on the water sector. It will affect us. It will affect the cost recovery ratio and so on. Next slide, please. From this chart, you can see the per capita share of available water resources, liter per capita per day, as we are comparing Jordan with other countries. And you can see Jordan, it's the lowest country, 127 liter per capita per day. It means and if you add the non-revenue water, so 50%, so we are considering around 60 to 65 liter per capita per day is the share of the Jordanian, or the one who is living in Jordan, after we are reflecting the non-revenue water. So it's one of the lowest share in maybe in the world. Next slide, please. So the main pillars that we are doing our planning, or we are focusing when it comes to our strategic planning or any kind of development for the future, we are focusing on the main 5 pillars: integrating the management of the water resources, improving the quality of water and wastewater services, optimizing the use of energy source in the water sector, engaging the private sector in the implementation of the strategic projects, and supplying water for agriculture, industry, and mining. Next slide, please. So when it comes to the pillar number 1, integrated the management of water resources, we are trying to enhance our one of the main strategy direction in the water sector, that we are trying to enhance our water resources. We are trying to push forward for the non-conventional water resource utilization as much as we can, and we are selecting 2 main direction in this way. We are focusing on we start to focus on the desalination of the seawater. We are still far away of having a project. We don't have any desalination, just a small intervention. But right now we are in the process of developing what we call it national conveyor project. It's one of the big. I think it will be one of the biggest desal project in the region. It's still under the tendering, and we are expecting by the end of this year to receive the financial and technical proposal. Based on that, we will see how can proceed for that project. Also, we are in the process of enhancing the surface water storage. To be honest, most of the potential areas in Jordan, it's already covered with dams. We have, I think, 15 dams. And right now we start to face a challenge in this dam, the sedimentation, the cleaning of the dams. It's a very expensive issue, but most of these dams, they are used for the agriculture purposes, except 2 dams, they are with multi-purpose of utilization, including the drinking water. Also, we are trying to enhance the treated wastewater utilization. As I told you at the beginning, we are I think Jordan is a pioneer country when it comes to the utilization of the treated wastewater. We are pushing behind, even increase that amount of water, the treated wastewater, and most of the treated wastewater consumed by the agriculture sector, either through direct utilization around the treatment plants, which was but based on a certain criteria, certain legal framework, and some kind of rules and regulations for sure, and or the big portion of that water it mixed with other surface water in a certain dam, then it would go for agriculture activities. Please, slide number 2.
Excuse me, sir, just a recommendation, if you can maybe ask quickly, not focus
yes.
on all your slides, just to let a little bit more time for the following.
Yes, sure.
Sorry for this.
No problem. The pillar number 2, improving the quality of the water and wastewater services. In a nutshell, we are focusing to enhance the water and wastewater infrastructure by expanding our services, improving our services, and by rehabilitation the existing assets. So all these kind of interventions, it includes either replacing of the water network, or expanding, or expanding of the wastewater, building new treatment plants, and so on. All these should affect the non-revenue water reduction, increasing the number of treated wastewater treatment, and so on. So please, slide number 3. Next slide, please.
I'm sorry, there is no other slide.
No, it should be. We still have a few slides later on. If you can go back to the 5 pillars, I will continue from that point.
Okay, I have them.
You have them? Okay, good.
Yeah. Let me share again.
Please, thank you. Yes.
Okay.
The previous one, please. Just okay. Slide number. Yes. The one before, please. Yes. Okay. So the pillar number 3, optimizing the use of energy source in the water sector. We are pushing heavily behind enhancing the energy efficiency in the water sector, as well as we try to adopt many renewable energy solutions or potentials. But this kind of renewable energy projects, it's really a big challenge, because we need to go through complicated processes and dialogue and mechanism with the energy sector, and this take us back to what we call it nexus and this kind of cooperation. But in a way, we are pushing behind that direction to enhance our energy efficiency utilization in the water sector, as well as to introduce as much as we can renewable energy in the water sector. Pillar number 4 is the private sector participation. And generally, what we are looking for is as much as the water sector is expanding and getting more complicated. So it's a good way to have the private sector as an operator or as a partner with the water sector. And this kind of partnership, it must push us as a water sector to enable our environment to absorb them and to get them in a clear mechanism, with a clear mechanism and a clear kind of cooperation. So we have, as I mentioned at the beginning, the DC project. It's on a BOT mechanism and modality, as well as we have a summer treatment, wastewater treatment plant. It's a BOT project also. So we have many kind of cooperation with the private sector. And we are trying to expand as much as we can for the coming few years. Next slide, please. The pillar number 5 is supplying water for agriculture, industry, and the mining. We are in our strategic direction. We keep the other sectors in our mind, not just the household or the municipal sector. We are trying to keep in our strategic direction the agriculture, industry, and mining, taking into consideration that the agriculture is the biggest consumer sector in Jordan. Lead us to have we are trying to have actually more kind of policy dialogue with the agriculture sector in order to reach some kind of a clear understanding for the both situation of the both sectors, which can help us in having the most effective and efficient kind of output and outcome when it comes to the water utilization of the agriculture sector. Next slide, please. I would like to show you our water budget when it comes to the resources and utilization. We have the surface water, groundwater, treated wastewater. So in total, around 1,000 million cubic meter. You can see the domestic, almost domestic, and the agriculture. They are almost at the same level when it comes to the total consumption. The industry, we don't have that much industry in Jordan, so it's still small. They are consuming around 36 to 40 million per year. But the agriculture and the domestic, they are the biggest consumer sectors. Domestic means which is the household level, everyone connected to the water network. And you can see the second chart that how the treated wastewater is going up from 2007 until 2020, and how we are our policies, and we are pushing behind the increasing the utilization of the treated wastewater. It's one of the main strategy direction that we are trying to enhance the treated wastewater utilization. It's mainly in the agriculture sector. Next slide, please. I think we need to skip this one. This table is showing just an example of how we are developing some projects regarding the water, the new water resources. But I don't think we need to have to go through them right now. The other slide, please. Next slide. In this chart, you can see just in a quick that how we are the cost of the water, and how the cost is going up over time because the increase of the energy, the increase of the population, and so on, and the new investments, and how we are subsidizing the water sector. And we still the water sector is subsidized heavily by the government, and this is one of the main challenge financially. To be honest, we cannot rely on our own revenue. We still have to get some money from the Ministry of Finance, and this kind of challenge actually affect us when it comes for the new development of new projects. But we are trying over the coming few years maybe to reform our water tariff and to change it, and to reach for a certain point that we can at least cover our O&M cost, the operation and maintenance cost on a yearly basis. I don't think we can reach our to cover all our costs, including the infrastructure. But anyway, this is our goal over the coming few years, but it's still not clear how we can when we reach that. Next slide, please. This is another chart that shows some indicators about the water sectors: the liter per capita per day, the connection ratio, non-revenue water, the dam storage, the connection to the wastewater network. And I think in Jordan, we are comparing to the region, we are one of the best countries when it comes to the wastewater network connection, the coverage, I mean. But we still have many challenges, the non-revenue water, as well as all these kind of indicators. As much as you are improving these indicators, it means that you are investing a lot of money. And the investment that for sure is not coming for free. It's come either, as I mentioned, from grants or loans. And most of the investment comes from loan. And the loan is a big challenge on the water sector. At the end, I would like just to mention that the water sector is not it's just one single institution, the Ministry of Water and Irrigation. We have many other institutions working together with the Ministry of Water and Irrigation. We have Water Authority of Jordan, we have the Jordan Valley Authority, as well as we have 3 water utilities that they are covering the 3 parts of Jordan: the northern part, middle part, and southern part. So most of our water and wastewater services on a daily basis, they are managed by water utilities. These water utilities, they are owned completely by the government. So they are, yes, companies, but they are public state companies operated based on a certain criteria and indicators that the government is following up against them. And thanks for your time, and I'm open for any question. Thank you.
Donc, merci beaucoup, Monsieur Adelwahiri. J'ai oublié de préciser que vous êtes l'assistant du secrétaire général pour la planification hydrologique, la planification stratégique au ministère de l'eau et de l'irrigation en Jordanie. Donc, c'est pourquoi vous nous avez présenté toutes ces informations très intéressantes. Alors, nous avons encore donc notre ami Salamé qui va présenter quelques slides aussi sur la Jordanie. Donc, je vais lui demander d'être vraiment très attentif pour ne pas dépasser 10 minutes, de façon à ce qu'on puisse éventuellement encore poser quelques questions et conclure en dépassant peut-être notre heure prévue qui était maintenant, de la dépasser de 15 à 20 minutes si c'est possible, mais pas plus. Donc, Salamé.
François,
oui.
On peut aller jusqu'à 18h, hein, sans problème. Voilà.
Bon, alors.
Voilà, ne nous stressons pas, allons jusqu'à 18h, il n'y a aucun souci. Donc,
si on peut aller jusqu'à 18h, donc ça nous permettra, après l'exposé de Salamé, de poser, de discuter 1 ou 2 questions complémentaires et de conclure. So Salamé, the floor is yours.
Thank you. First of all, thank you, Francois, and for asking me to complete everything in 10 minutes. But please, next time, ask this question to all presenters, not only to me, okay? So I will talk about 2 main subjects because, as Francois said, we have only a limited time. The first one will be the Jordanian water demand, and the second one will be the use of non-conventional water resources in Jordan. I think you can see my screen. Am I right? That presentation.
Yes, that's perfect.
Okay. So first of all, when we are talking about water demand in Jordan, we have really a major issues here. The first one is that when any country wants to plan for the future water demand, usually it's being calculated only for the natural increase, the fertility growth. But in the case in Jordan is different, because in the last 3 decades, we receive 3 major immigrations in the year 90, in the year 2003, and in 2011. So what's happening is that from time to time, while we are planning for the natural demand, we are receiving much more population through influx of refugees. The other thing is that I think also it's existing in many other countries, is that there is also internal immigration between the countryside or the rural areas to main cities, like what's happening now in Amman. And that really increased the demand in a shocked way, and also affect the implementation and the master planning of the infrastructure. Of course, I think Muhammad, he explains many things about the water resources. We have 3 major water resources sources in Jordan. It's the groundwater, surface water, and non-conventional water, which is mainly the reclaimed water. Here, when we are talking about the groundwater, exactly as Muhammad said, the half of this groundwater, we are consuming double of the renewable groundwater. We are consuming like double of the existing renewable groundwater. When it's also about surface water, I want just to give you a figure also to compare between Jordan and Spain. We are almost also capturing half of the available runoff water. It's the same like what Javier said. So we have like 600 million cubic meter as a long-term average of runoff, and we are capturing half of this quantity. So here also, when it comes to water demand, also we can say that the other sectors are also impacted by water demand. We talk about the increasing in population that will impact the increasing in demand on municipal water. It's also affecting the irrigation water, and to a certain extent the industrial water. We are using only like 36 million cubic meter for industrial water. Here for this slide, you can see the supply versus demand for different purposes. First, almost 3.3% is using of the available water is used for industry, like 50% or 48.6% is for irrigation, and 47.5% for the municipal uses. And what's happening is that a big portions of the water that's being used for irrigation is now being utilized for municipal. When it comes also to supply, the available renewable groundwater is 450 million cubic meter. Like 170 is non-renewable groundwater. The surface water is like 307 million cubic meter, and the reclaimed water is like 167. I do not want to explain also a lot about how each type of water resources is being used for different purposes, but you can see, for example, that we are using reclaimed water only for irrigation purposes, and most of the water that being used for drinking is the groundwater. This chart shows the demand versus supply for the municipal sector from the year 2021 to and its expectation for the year 2040. Of course, this prediction was based on having the refugees, especially the Syrian refugees, staying in Jordan, and with a similar natural growth to Jordanian refugees. And you can see that now there's a deficit, and this deficit will be increased until the year 2029, which is the year that the national water conveyor, and I will have some explanation about it, will be utilized on its full capacity. But afterward, also we are expecting also increase in deficit because of increasing population. This is similar calculations, but for the irrigation water in Jordan Valley in Highland. In Jordan, when it comes to agriculture, we are dividing the country into two main geographical areas, which is the Jordan Valley, which is the areas below sea level, and the highlands. And we have The Jordan Valley is one of the main agricultural areas, but we have also some farms in the highland. It's here a similar calculation for the industrial sector. Now I will come to the second subject, which is the mobilization of non-conventional water resources. Again, when it comes to the when it comes to the reclaimed water, Jordan is using, as Mohammed explained, we're using a big portion of the reclaimed water for irrigation. And I just saw a question asking about for irrigation of what? It's for irrigation of what they called constructed crops. It's the crops that it's the trees and the crops that being cooked. This is what the reclaimed water is being used for. And most commonly it's the domestic wastewater. For the industrial wastewater, it's the quantity is few, and part of the industrial wastewater is being also reused in the same industry or other industries. When it comes now to the national conveyor, which is Aqaba Amman water conveyor, it's our recent project here in Jordan. It's expecting to provide like 300 million of desalinated water from the Red Sea in Aqaba to Amman. Water is expected to be desalinated in Aqaba and afterward to be pumped to Amman. In some areas it will be pumped, and in some areas it will be falling down, so maybe it will be also generate some energy. If that's possible, part of the energy will be used from solar panels. And there was also, I saw a question about the cost. Officially, the Ministry of Water and Irrigation is stating that the cost will be like 2 billion USDs. 2 billion Jordanian dinars. It's like 2.8 billion USDs. But until now, the financial offers are not being opened. So it could be something more than that, because as you know, the costs are, in general, the cost of the material and construction is being also increased. It will be a kind of PPP project, and BOT, build, operation, transfer, similar to what Mohammed explained about also DC. The cost of a cubic meter is expected to be like $3 US, 2.7, 2.8 US dollar. Here we mean the cost of desalination and pumping to Amman. So it's expensive project with expensive water, and now it's in the bidding period. I try to summarize as much as I can, and we will leave, of course, a room to questions that we can answer later. Thank you.
Donc, merci beaucoup, Salamé, d'avoir été rapide et synthétique. Ça nous permet quand même d'avoir encore quelques minutes. Donc, pour déjà conclure, hein, moi je voudrais remercier les orateurs qui ont préparé des exposés vraiment très intéressants. Où il y a énormément de félicitations dans le chat, donc je les retransmets avec plaisir aux orateurs pour la qualité de leurs exposés, aussi bien l'Espagne que la Jordanie. Je remercie aussi au passage les traducteurs, puisqu'il y avait beaucoup d'informations, ça allait très vite, et donc c'est un effort important de retranscrire en français. Moi, je retiens qu'on a deux pays vraiment très intéressants, parce que l'Espagne, c'est un pays qui a une planification très sophistiquée, avec beaucoup de données, beaucoup de concertation entre les acteurs de l'eau et beaucoup de modèles aussi, d'outils. Et la Jordanie, ben, c'est un pays qui se trouve dans une situation vraiment dramatique de manque d'eau, de ressources en eau très très faibles, avec une population qui augmente, mais déjà beaucoup de résultats, enfin beaucoup d'efforts ont été faits pour économiser l'eau, beaucoup de résultats. Donc ce sont des expériences très intéressantes pour les autres pays, même s'il reste encore beaucoup de problèmes à régler. Alors, je voudrais j'ai regardé les questions sur le chat et je vais sélectionner 2 questions parce qu'il se trouve qu'elles ont été posées, c'est la même question qui a été posée aussi bien à l'Espagne qu'à la Jordanie. Donc, chacun des intervenants pourra répondre. La première question, ça concerne donc le dessalement, hein, le dessalement de l'eau. Quels sont les coûts de l'eau qui est produite et est-ce qu'il y a des impacts négatifs sur la mer? Ça, c'est première question. Et la deuxième question, c'est sur les données, les informations qui sont nécessaires pour construire ces plans. Donc peut-être sur la première question, donc le coût du dessalement. Salamé vient de donner l'exemple de dessalement à partir de la mer Rouge. Peut-être pour l'Espagne, si Javier ou Nieves peut donner quelques chiffres sur les coûts d'investissement et les coûts le coût de revient du mètre cube et l'impact sur la mer Méditerranée aussi.
Excuse me because I've lost the translation, but I think that you're asking for the cost of desalinated water and also for the environmental impact of it on the Mediterranean region. Yes, that's it.
Yes.
So I'm sorry. Well, the cost of desalinated water varies a little bit, and it has been decreasing in the last years. So the cost was, the gross estimation of cost in 1995 was around €1 per cubic meter. I'm not an expert in this. And nowadays it ranges around 0.4, 0.3. It depends on the need of pumping. So when you desalinate water, you always get water at a level 0. So there's always a need of pumping. So we have some desalinizator plants with a cost of 0.475 euros per cubic meter, and some range from 0.3, 0.24. I think it's the cheapest one. But starting from 0.3 at the exit of the desalinating plant, from there you have to add the cost of that pumping. And the other question was about the environmental impact. There was a question about the impact on the whole Mediterranean region. I think that's not something which can be, let's say, considered significant, because this is, let's say, irrelevant. The amount of water that we desalinate in Spain, which is 500 millions of cubic meters a year. So that's comparing with the volume of the Mediterranean is nothing, but it has sometimes important impacts, local important impacts, mainly on Posidonia meadows, and also with the high concentrated in salt discharges, which could have also a local impact. All the projects that we have for these plants are subject to an environmental impact assessment, and special studies about the currents and how this salt is going to move are carried out. So I think there's local impact if it's seen like that, but there are different type of mitigation measures to spread this in a big area, as big as possible, to reduce the local impact.
Yeah, I think also they want also to hear from me about the Jordanian project, the Jordanian desalination. Yeah, yeah. Look, for the Jordanian project, exactly as Javier said, the price of the desalination nowadays is being reduced. It's now like again, exactly as Javier said, it's like 0.4 euro per cubic meter, and this technology is also evolving. So there is also an expectation for this price to be reduced. But in the case of Jordan, you are talking about pumping for a very long distance, which is about 400 kilometers, and also for a very big elevation difference. And because of that, the biggest portion of the cost is coming from the pumping. And for that, we are expecting a cost of 1 cubic meter reaching Amman of like 2.6 or 2.5 euros per cubic meter. Also, you have, because this will be a kind of public-private participation project, so there will be also a margin for the investor, and because of that, we are expecting this relatively high price. Of course, it will depend on how the bidders will submit their prices for the capital and operational cost. Very quickly, also again about the environmental impacts, it's the same like what Javier said. It's a matter of the main environmental impact of desalination is the brine water, which is a very high concentrated saline water. And it's a matter of to try to distribute it as much as you can, and not to leave it concentrated in a certain portion of the sea.
Okay, thank you very much, Salami. It was really coherent with what Spain and Jordan said. Donc, je vais poser maintenant une autre question, car ça a été demandé dans le chat aussi bien par rapport à l'Espagne que par rapport à la Jordanie, et concernant les données, les informations nécessaires pour bâtir ces plans. Donc, on a l'impression qu'en Espagne, il y a vraiment beaucoup d'informations. D'ailleurs, ça a été dit que c'est très important justement de mesurer, de contrôler la situation qui peut évoluer. Mais là, donc on se demande, certains pays se demandent si, pour l'Espagne, comment on arrive à fédérer, à rassembler toutes ces informations, à les rendre homogènes. Et c'est un peu la même question par rapport à la Jordanie, puisque c'était indiqué qu'il y a la construction d'un système national d'information sur l'eau. Donc, un des participants demande quel est le coût de ce système et comment il peut être financé, parce qu'on sait que les mesures coûtent cher. Les banques de données coûtent cher, mais les mesures coûtent encore plus cher que les bases de données. Donc peut-être si nos amis jordaniens peuvent répondre en premier.
Yes. Would you like me to?
Yeah. Mohammed, please go ahead.
Yes, thank you. Yes, you are right. Having the right information, either in the right quality and the quantity, it's the best way that will help you to do your planning for the future. Without data, you cannot do the planning. It's a challenge in Jordan. We are trying to build what we call it National Water Information System. There was a project in 2017 in that direction, but we need to do more on putting all the databases together and to connect them and to enhance the kind of analysis and the data gathering mechanism. As I mentioned, we are not just one single entity in the water sector. We are around 6 institutions If you add another institution outside the water sector, you are thinking of Department of Statistics and Meteorological Department, the other departments, Ministry of Local Development, and so on. So all these together, we need to make sure that we are reading or we are connecting the database together. This is from the outsider point of view. From the internal side, yes, we are pushing behind enhancing the quality of the data, the quality of the data that we are gathering, enhancing the quality and the capacities of analyzing this data. There are many interventions over the coming few years. There is a project right now with the World Bank, part of one of this. It's a small component, part of that project, but it's supporting the drought management mechanism as well as the water information system. We are trying to put it again on the surface, this water information system, and to make it like a national water information system that will include most of the our databases, to connect them together, and so it will help the policymaker and the policy developers at the ministry to see and to read the future in a proper way. Thank you.
Merci beaucoup. Est-ce que l'Espagne peut dire juste un petit mot sur les systèmes d'information, soit au niveau du bassin, soit au niveau national?
Well, I'm not sure if Nieves wants to say something. I'm in charge of the national system in Spain for the water planning. And well, of course, there's the cost of technology, which is probably the less important part of all thing. So what is important here is the data, the governance of the system to make everyone aware of what is the need. Also, the standardization is of paramount importance in all this. And in the end, in Europe, at least, we have some initiatives which just are the drivers for the implementation of many of our systems. We have a system in place for water allocation, the water registry. We have a system for wastewater permits, which is the national census of wastewater discharges. We have the information from the networks, the monitoring networks, being them from quality, biological data, physical chemical data, also the one for quantity of water, being it surface water or groundwater. And then we have the system for hydrological planning. And some of these European initiatives like the INSPIRE directive, which has implemented some the concept of interoperability, where all the GIS information, the geographical information is shared by the different authorities in a common way. So standardization has been carried out at European level. In the rebasing management plans, there's also has been a great effort in Europe to standardize the information. And nowadays we are facing another challenge, which is the directive or decision on high value data, which all the institutions in charge of data should share this through interoperable services, which enables us to have more information without the cost. But the important thing is to have the data. It's not just so much about technology, but the acquisition of the data in a very standardized way. And the cost of our measures, you can think that we have 1,000 measures in our rebasing management plan, and the cost of them is 37,000 millions. So just the cost of having all the information stored in a compatible way is nothing compared to the cost of the measures. So, well, it's important to invest in these systems.
Ok, merci beaucoup. Alors, je vous propose d'arrêter là parce que vraiment l'heure est avancée. Ce que l'on fera, c'est comme d'habitude, mettre à votre disposition l'enregistrement de cette conférence. Donc, vous pourrez revoir les diapositives. S'il y a des chiffres qui sont passés trop vite, vous pouvez les retrouver, les entendre sur notre chaîne YouTube. Également, donc, les quelques questions qui ont été posées auxquelles on n'a pas eu le temps de répondre, On essaiera de vous apporter une réponse avec les intervenants, que je remercie encore une fois chaleureusement. Et puis, je vous donne rendez-vous pour le 7 septembre, puisque nous aurons une 4e conférence le 7 septembre, avec sans doute comme pays qui vont présenter leur expérience, l'Algérie et l'Algérie et l'Albanie, peut-être l'Égypte. On est en train de finaliser le programme, mais ce sera donc des 2 pays qui vont présenter leur expérience le 7 septembre. Maintenant, Alain, si tu veux dire un mot pour compléter.
Simplement, je vois que dans les questions, on pose la question sur le Maroc. Le Maroc, c'est déjà passé. Donc, vous pouvez retrouver la présentation sur le site YouTube en tapant Institut Méditerranéen de l'eau et en cherchant un peu, vous allez retrouver la présentation qui a été faite sur le Maroc. Et de mémoire, c'était en même temps que Malte, non, François? C'est ça? Voilà, exactement. Donc, je vous rappelle, il y a eu la France, il y a eu la Tunisie, non? La Tunisie, donc le Maroc, Malte, aujourd'hui la Jordanie et l'Espagne, la prochaine certainement l'Algérie et l'Albanie. Et puis on travaille sur, comme l'a dit François, sur l'Égypte, peut-être la Turquie. Et voilà, donc ça permettra d'avoir donc un bon tour d'horizon, pas de tous les pays, mais en tout cas d'une dizaine de pays méditerranéens qui vont pouvoir donc alimenter nos réflexions sur les 6 sessions dont je vous ai parlé en introduction. 6 sessions de notre forum méditerranéen de l'eau, je vous rappelle, du 29 au 31 janvier prochain. Et donc, bien sûr, avec un kick-off, un démarrage, donc un lancement à Valence le 18 octobre prochain en Espagne. Donc, vous êtes tous, bien sûr, invités, conviés. Voilà, mais n'hésitez surtout pas à aller revoir nos présentations. Tous les PowerPoints les émissions sont enregistrées en français, en anglais. Donc, vous pouvez facilement revoir ça tranquillement chez vous. Et surtout pour ceux qui se sont inscrits et n'ont pas pu participer aujourd'hui. En tout cas, merci beaucoup pour la confiance que vous avez à l'Institut Méditerranéen de l'eau. On essaye de servir le mieux possible nos membres. Ceux qui ne sont pas membres, on les invite. Faites-vous connaître, notamment nos amis jordaniens. J'en profite de leur présence aujourd'hui. C'est important que l'Institut représente l'ensemble de la Méditerranée. Nous allons avoir donc prochainement arrivé des membres italiens. L'Italie était mal représentée au sein de l'IME. Ça va être comblé, donc ça nous fait plaisir. Bien sûr, l'Espagne, le Maroc, l'Algérie, la Tunisie, l'Égypte, Malte, Chypre sont des pays qui sont là depuis longtemps. Donc, merci à nos amis jordaniens de voir comment officiellement rejoindre. Nous avons des consultants, mais ça serait bien d'avoir des institutions présentes au sein de l'IME. Donc, le message est transmis. J'espère qu'il est bien reçu et à très bientôt à tous. Donc, bonnes vacances et au 7 septembre.
Merci.